Experimental studies. Let's explore how controlled experiments work in biostatistics. Before we dive in, let's define some key terms. A subject is an individual who participates in the experiment. A factor is an explanatory variable being studied. An experiment may address multiple factors simultaneously. A treatment is a specific combination of factor levels that a subject receives. Consider a hypertension treatment trial with 2 factors. Factor A is a health education program with 2 levels, active or passive treatment. Factor B is pharmaceutical with 3 levels, medication A, medication B, or placebo. Combining these gives us 6 treatment groups of 20 subjects each, for a total of 120 subjects. The response variable is the change in systolic blood pressure after 6 months. Experiments are built on 3 critical principles. First, they must be controlled. A control group, which receives no treatment or a placebo, is essential because you can only judge a treatment by comparing it to what happens without it. Many factors can affect outcomes, conditions change over time, and the placebo effect is real. Second, they must be randomized. Randomization uses chance to assign subjects to groups, which balances lurking variables and prevents confounding. Third, they must be blinded. Blinding means the response is measured without knowledge of which treatment a subject received. Single blinding hides the treatment from subjects. Double blinding hides it from both subjects and investigators. Let's see randomization in action with a nicotine patch trial. We have 60 smokers in our subject pool. Through random assignment, 30 subjects are placed in the nicotine patch group and 30 in the placebo patch group. After the treatment period, we compare smoking cessation rates between the 2 groups. The randomization method works just like our SRS example. Number subjects 1 through 60, then use random numbers to select which 30 go to the treatment group. The Women's Health Initiative is a landmark experimental study. Postmenopausal women were randomly assigned to 2 groups. One group received hormone replacement therapy, and the other received a placebo. Subjects were followed for about 5 years. Researchers tracked outcomes including heart attacks, strokes, and breast cancer occurrence. This experimental design allowed researchers to establish a causal link between HRT and health outcomes. To recap, experimental studies actively assign subjects to treatments. Factors and treatments define the structure of the study. The 3 key principles are controlled comparison, randomization, and blinding. Randomization balances confounding variables, and blinding prevents measurement bias.